In problem number 24, we're looking to write the equation of the line that has slope -6 and passes through this point. So what we're going to do is we're first going to think of our two templates, the slope-intercept form, y equals mx plus b, and the point-slope form, y minus y1 equals m times x minus x1. And our first go-to template is this one because it's just substitution, no computation. But to use this one efficiently, we need the slope, which we have, and we need the y-intercept. Now this point is not the y-intercept, right? This is 2 to the right and 5 up. This is not on the y-axis. So let's go to this form right here. So I'm going to say what it is we're going to do here, as I always do. I'm going to say I'm going to use y minus y1 equals m times x minus x1 with m equal to -6, x1. x1 is the first x value. x1, that 1 just tells us which one it is. It's the first x, and the first x, in fact, the only x I see is 2. So x1 is 2, and y1, the first y value, well, the only y value, the first one I see, and the only one I see is 5. So we'll just substitute in. So we'll get y minus y1, right? Now y minus y1, and y1 is that 5. So we'll get y minus 5 equals m, which is -6, times x minus x1, and x1 is 2. So let's put this into slope-intercept form. So we'll multiply through by the -6, so we'll get y minus 5 equals -6x plus 12, and then we'll add this 5 to solve this for y. So we'll get y equals -6x plus 17. And just so we can say what's happening here, this is our start value. That's our start value. So when we come in on this, start our observations here, we start with 17 units of output, and this is our slope. That's the rate of change. So in number 25, we're trying to find the equation of the line that has slope 4 and passes through this point. Now, our go-to are these templates here, and we go first to this one. Can we use the slope-intercept form efficiently? Do we have the slope? Yes, we do. It's 4. And what about b? Now, b is the y-intercept. So look at this point here. 0, -1. That means the x value is 0. We're not to the left of the y-axis. We're not to the right. We're right on the y-axis. So this point right here, that is b. So all we have to do is say this. What we're going to do is this. We're going to use y equals mx plus b with m equal to 4, b equal to -1. So just substituting into that template, we'll get y equals 4x plus b, but b is a negative, so we'll get 4x minus 1. There's our equation. Notice here that each time I did one of these problems, I said what I'm going to use with what information, right? Use this form, that template, with this information. Up here, use this form with this information. Okay, so I'm trying to make a good mathematical presentation. I'm not just looking for the answer. We're looking to make a good presentation so somebody can follow what we do. Now in number 26, we want to find the equation of a line. Write the equation of a line that's parallel to this line, but passes through this point. So once again, here's our two templates. I'm going to go to the top one first. To use this, do we have the slope? I don't have it directly, but I can get it, right? We have parallel lines. Our line is parallel to this line. Parallel lines have the same slope. So I do know here that this slope is -3. But to use this form efficiently, I also need b, and b is the y-intercept. Follow it over here. This point is not the y-intercept. We're in 4 units to the left of the y-axis. So since I don't have both these pieces of information, I'm going to go right to this form right here. So I'm going to use y minus y1 equals m times x minus x1 with m equal to negative 3, x1 equal to negative 4, and y1 equal to 6. Let's substitute. So we'll get y minus 6 equals m, negative 3 times x minus, be careful here, x minus negative 4. So we'll get y minus 6 equals negative 3 times x plus 4. Multiply through by that negative 3. We'll get y minus 6 equals, right now distribute that negative 3. So we'll get negative 3x minus 12. And then one more step. Let's just add this 6 to solve it for y. So we'll get y equals negative 3x, negative 12 plus 6 is minus 6. So this line here that we just created, this line here is parallel to this line. Notice this line crosses at 8, our line crosses down 6, but they both have the same slope. In 27, we're looking for the line that is perpendicular now to this line. Back in 26, we wanted parallel. Now we want perpendicular. And we do know something about perpendicular lines. They have negative reciprocal slopes. So the slope of the perpendicular, I'm going to write it like this. The slope of the perpendicular is, now just look at the slope that we have, change the sign, and take its reciprocal. Just flip it over. So we're going to change the sign, so we'll get positive 1 over 3. Right? Just change the sign here and flip it over. 3 is in the top, put it in the bottom, and it passes through this point. Back in problem number 26, we had parallel lines, right? Parallel, and parallel lines have the same slope. But now we have perpendicular lines, so we have negative reciprocal slope. Change the sign, flip it over. So we're going to use y minus y1 equals m times x minus x1 with m equal to 1/3, x1 equal to 12, y1 equal to 3. Now, I'm using this form here, right? I'm going to use this form rather than all the way over here. I'm not going to use this form. Even though I have the slope, we don't have the y-intercept, right? Let's follow it all the way back over here. This point is not the y-intercept. It's just some other point on the line. So let's substitute in. We'll get y minus y1, but y1, the first y, the only y we have is 3, equals m, or 1/3, times x minus x1, which is 12. Now let's take this 1/3 through, so we'll get y minus 3 equals 1/3 x, and now 1/3 times negative 12 is negative, and 1/3 of 12 is 4. One more step and we'll have it. We're trying to solve it for y, so we're going to add in this 3 to both sides. So we're going to get y equals 1/3 x, and then negative 4 plus 3 is negative 1. So our equation is y equals 1/3 x minus 1. In 28, we still want to write the equation of the line that passes through these 2 points. So notice neither one of these is the y-intercept. So why don't we go directly to our point slope form. So we're going to use y minus y1 equals m times x minus x1 with m equal to, now we don't have m. We're just given 2 points. But if we're given 2 points, we know that we can find the slope using the slope formula, which is this fraction, y2 minus y1, right? The second y minus the first y, second y minus first y, over x2 minus x1, right? Second x minus first x. Let's just do this. We're going to get, all right, second y minus first y. Now, I'm just going to read left to right. The second y I see is 15, and the first y I see is 3. So I'm going to write this as 15 minus 3. Make sense? Second y, 15, minus the first y, 3. Over the second x, right? Second x minus the first x. And when I look at this up here, left to right, the second x is negative 4 minus the first x is negative 2. I just need to be careful with those negatives. So it's going to be the second x, negative 4, minus the first x, which is negative 2. Let's run this down. We're going to get 12 over negative 4 plus 2. It's going to give us 12 over negative 4 plus 2 is negative 2. So we're going to get the slope here is negative 6. And then our x1, now if I'm reading left to right, the first x I see is this one up here, negative 2. And y1, the first y I see is this one, the 3. So let's substitute. So we're going to get y minus y1, which is 3, equals m negative 6 times x minus x1. Be careful with these negatives, negative 2. Right? So this is y minus y1 equals m that we found to be negative 6, x minus x1. Let's keep going here. This is going to give us y minus 3 equals negative 6 times x plus 2. Let's distribute that negative 6. We'll get y minus 3 equals negative 6x minus 12. And one more step. Let's add that 3. So we're going to get y equals negative 6x. And then negative 12 plus 3 is negative 9. There's our equation. Y equals negative 6x minus 9.